Assalamu alaikum wa rahmatullahi wa barakatuh. Okay, guys, this is a very recent upload. This is the skies in Brazil. Now it seems the helium and the ionized atmosphere of the brown dwarf star were basically in the thick of that cloud. We discussed that in earlier vlogs, yesterday and the day before that. And I've mentioned it also in the Comet 45P Honda as it arrives. That I made a very uh, short mention about the helium cloud being in our atmosphere and how it doesn't belong in our solar system, and that is indicative of a brown dwarf star being in our solar system. I want you to watch this, and then we'll talk about. I'll take you somewhere else where you can find a presentation of a physicist and his thoughts on the matter, or sorry, her thoughts on the matter.
Guys have got to see this. This is in Brazil, Sao Carlos, Brazil. I'm not quite sure why in the world. I don't think I've ever seen the sky that color before. This is making its rounds on Facebook. I was beginning to wonder if it was video editing, because as you just saw, it changed color right then and there. Is this because of geoengineering? Is it because of what? I mean, this is craziness. You can clearly hear the wind in the background. I'll turn it up if you'd like. Let's replay it again. This is something else, though. That's incredible. I want to know if you guys have ever seen the sky that color before, that red, and then change just like that. This is truthfully strange. The signs are all around us. Let me know what you guys think in the comments.
Now, I've witnessed some of it yesterday, but it was very small pockets. Nothing as definitive and as substantial as this. I want you to watch this, and then you'll see where we are heading with this.
About the cloud that we have moved into on a galactic level. So our resident physicist has given us her thoughts, and I thought I would share it with everyone. It kind of helps bring in the science to what we're seeing and kind of help us begin to get a handle on this. So I'm going to read this so we can read it together and learn together. Helium in the solar system, a physicist's thoughts. There have been some reports that there is, at the moment, a large amount of helium in the solar system. Large clouds of dust that have been observed have therefore been reported to be mainly made up of helium. In this article, I discuss the likelihood of that and where it may be coming from. Figure 1 shows an image taken of what I believe is the brown dwarf binary system that has been draining our sun of energy. This image was obtained from the Cosmic Artifact Research website. This website contains many other such amazing images of strange objects in close enough proximity to our sun to be photographed from the Earth's surface. Hey, how about that one, folks? Image of the binary star system right here. The large amount of ionized material around the larger star, right here, makes this star very likely to be a brown dwarf star, and its smaller companion of comparable brightness is very likely to be a brown dwarf star as well. Now, I'm going to show you figure 2, and we're going to reference this. It's very important that you understand the colors here. Figure 2, emission spectrum of hydrogen and iron with 4 lines in the hydrogen spectrum and many lines in the iron spectrum spread out over all the visible wavelengths. Now, let's read what this figure is referencing to. Now, brown dwarf stars are made up of mainly iron, but they do absorb material in the solar wind of other stars and also ionize this material, producing heat, and eventually start fusing some of the absorbed material on their surface. Iron can be ionized, but it cannot release energy under fusion reactions. However, As long as our sun still has plenty of hydrogen to burn, and it does, its solar wind will be made up of mostly hydrogen. And so the brown dwarfs that have come close to our sun will be able to absorb this hydrogen, ionize it, and fuse some of it to helium, and thus be able to emit a lot more light than it would if not able to fuse hydrogen. Now, ionized hydrogen has a certain color associated with it that comes from the emission spectrum of hydrogen, shown in figure 2 above. All right, that's this one right here, so pay attention. The emission structure of hydrogen contains 4 lines in the visible spectrum, light detected by the human eye. There is one red line, a light blue line, a dark blue line, and a violet line. Each line is responsible for a transition of the electron in the hydrogen atom from one energy level to another, which also releases a photon of the exact wavelength associated with each of the colors in the emission spectrum. Red light has a wavelength of between 650 nanometers and 750 nanometers. The red line in the hydrogen emission spectrum has a wavelength of 656 nanometers. Now, when we combine the colors of all 4 lines in the hydrogen spectrum, we get a reddish purple color, which is shown in figure 3. How many of us have seen this all across the country? Our sunrises, sunsets, thunderstorms. Seriously, folks. All right. Figure 3. Ionized hydrogen gas glows in a reddish purple color, which is a combination of its 4 emission lines. On the other hand, the iron emission spectrum shown below, the hydrogen emission spectrum in figure 2 has many lines spread out over the whole range of the visible spectrum. But there are more blue lines than any other color, so ionized iron should glow blue. However, we should not confuse iron in this plasma state with the iron that seems to have entered our atmosphere from space. When not in its hot ionized state, and after entering our atmosphere, the iron would combine with oxygen, and we would therefore get iron oxide, or rust, which would look red and make our atmosphere look red. Huh. How many of us have seen that? All right, figure 4. Right here, star and figure 2, side by side with the hydrogen, in a discharge tube glowing reddish purple. Comparing the 2 reveals that the color around the white center of this star is made up of some purple associated with the presence of hydrogen. But there is also quite a bit of yellow and red, and even some green further out from the surface. Ionized helium glows yellow and red or orange. Now, the colors of the outside portion of the star, which I believe is a brown dwarf, are mainly a combination of purple and yellowish red, with some green present as well. This suggests that the star is ionizing hydrogen in combination with other elements. Helium is probably one of those elements because its emission spectrum contains a strong yellow line in addition to red, blue, and violet lines as shown on the left of figure 5, right here. This causes ionized helium's glow colors to be yellow and red. Often the hotter part is yellow and the glow around it is orange or red, as shown on the right of figure 5. The green color is usually associated with the presence of nitrogen. Okay? Y'all white South Park? Okay? All right. Another reason why helium is likely to be present is that there is some helium in our sun's solar wind. However, the solar wind is only 8% helium, and the amount of red in the ionized material suggests there may be more than that around the star. Of course, some will come from fusing hydrogen into helium, but this is unlikely to account for all the helium in the ionized cloud surrounding the star. So, where would the extra helium come from? Well, if our sun was to run low on hydrogen for fusion reactions, it would have to start using helium. This would cause our star to heat up because helium fusion reactions have to happen at a higher temperature than hydrogen fusion reactions. Also, our star would increase in size and it would also turn redder in color. Essentially, it would start turning into a red giant. We don't want to be here for that. This would obviously have devastating consequences for our planet, as the sun would then heat up far more than normal. Since this has not happened, it is not likely that our sun has run low on hydrogen yet. However, we know that the brown dwarf binary system has not been close to our sun for long, so it probably belongs to another system. Now, that's interesting. This system may well have a red giant star in it that is using helium as its primary fuel, in which case the solar wind from this red giant star would mainly be made up of helium, which would then be absorbed by the brown dwarf binary system. This would also explain why there is so much more helium filling this portion of space. This red giant may even be the central star in the system. As I have written before, there is some likelihood that our sun is actually part of this system, has a large ecliptical orbit around the central star, and is now close to its perihelion position, which has brought it close to the central star and close to the other stars that may orbit the central star in a more circular orbits. And since space close to the central star would be filled with helium from the central star solar wind, our solar system would also fill up with clouds of helium at this time. So, what is our physicist telling us here? Let's start looking at our solar system, our star, not being the primary star in the system. Maybe we should be...
Now, I've maintained this, that the primary star is An-Najm thaaqib, and that's the star that's got other stars orbiting it as well. And I guess we're sharing a barycenter with it, so there's no reason to believe if it was a primary star and it's at the top of the tier system, then all the binary stars would actually be orbiting around this particular star. That includes our solar system as well, subhanallah, which is very interesting, because the kalam of Allah subhanahu wa ta'ala clearly states that the sun itself has an orbit, right? And it goes on its orbit, right? Uh, uh, um, so it swims in its orbit. So subhanallah, it's Jeep, that we're making discoveries outside of our solar system that corroborate that evidence pretty clearly here. Now, it's nothing accurate simply because all of this is based on a hypothesis, and it's a theoretical almost. I mean, certainly we're using evidence, and it's verifiable stuff. There's bits of backyard science, but I mean, a lot of it is real physicists. There you go. This is one of them who's done this white paper. And then you've got astrophysicists, you've got theoretical physicists, you've got astronomers, and then you've got professional researchers, all of whom are basically pointing towards the same direction. It seems, subhanallah, what's in the Quran. At least this is my very, very, very uh, fickle understanding of events as they are, that where it's the proton star itself, which is the primary star of the systems, is the An-Najm thaaqib, and it has its trajectory and when it goes out in its trajectory, subhanallah, that's when we're expecting the lion's share of these natural disasters as well, and it should by all means take with it what it brought with it. And it doesn't mean it's just going out in its trajectory, that means we will continue out in our trajectory as well. We all have our orbits that have been assigned to us and defined by Allah subhanahu wa ta'ala, and each celestial body will maintain that to the nth degree, subject to the discretion of Allah subhanahu wa ta'ala, of God. So it's interesting that all of this research is all pointing towards the possibility of this. Again, I can only ask and try to engage our beloved ulama kiram in this uh, discourse and this discussion. Again, for any one of you who are interested, please study the science PDF, um, uh, work through it, and then maybe perhaps go to the channel after that and work backwards on all the content that's been archived onto it, and then see where that takes you. Anyway, Jazakallah khair wa hasanul jaza for your time. Wassalamu alaikum wa rahmatullahi wa barakatuh.